Wonderful. So here's what we're going to learn about today. So first we look into version control systems and understand what that is. Then we'll learn about a little bit about the examples of version control systems. Then we'll ask the very, prominent question, why Git? Why do we use Git? Then we look into GitHub and, the most popular interface, and we'll see all of its features and components. Then we'll have components of GitHub, which is basically the explanation of the most important components that comprise GitHub. Finally, we'll end today's session with some basic Git commands and also a hands-on session for you to learn the same. So here we are. So this is all about version control systems. Now, before I get started, I have a question for all of you. I'm sure many of you here in this audience have used both Google's products and Microsoft products. I'm sure you've used MS Word as well as Google Docs. So can any of you tell me what is the major difference you see in these two? Like one very prominent difference. Anyone can feel free to answer. You can either unmute or you can type it out at the chat as well. Anyone? Like a very prominent difference you see between MS Word and Google Docs. One is completely online. Okay. Okay. Vishwas says one is completely online. Any other responses? The user interface. Amazing. Amazing. And anything else? Anything else? I'll just wait for like a few more seconds. These are correct answers. They're well valid, but there's one more point I want you guys to focus on for the sake of, this particular topic, version control. Think in terms of that. In anything you can think of in terms of like versions, perhaps. All right. Okay. Okay. Wonderful answer so far. So basically, if you think about it, when you do MS Word, right? When you put basically edit a document in MS Word, what happens is that once you make a change, let's say, for example, you've written one paragraph or you've written one essay, and then you realize that the conclusion of that essay, you want to change it. So you reframe the conclusion of that essay and then you save it. You save the Microsoft Word document. Now, when you open it again, there will be no trace of the previous conclusion that you had written. As in, you reframe the conclusion, right? So there'll be no trace of the first conclusion that you've ever written. But that's not the case with the Google Docs. With the Google Docs, if suppose you make some changes, there's always going to be a version history. In fact, I will just show you here what the version history looks like. So if you can see here, this shows different checkpoints in time and different versions or different changes that were made to the doc at that particular time. So that means that if I made a particular change and then I didn't like that change, I can revert back to what it was previously. Am I audible? Hello? Maybe.
Yeah, you are. Go on.
Yes.
Okay. All right. So that's what I mean. In a Google Doc or Google slide, you can basically see the versions of what you edited. You can see the edited version of maybe some text. In the case of Google Slides, it's some PPT. In the case of spreadsheets, you can look at some Excel version changes. That's the advantage of Google products. But what if you want to look at the same version history for a code? That's where version control systems come into play. So these version control systems basically allow for the tracking as well as the managing of changes that are made to a project. And this project could be software code. So this is what it does. It allows you to manage as well as change and store different versions of those changes that's made to a software code. So you can always revert back to the changes if you didn't like what you already made. Now, it's not, and if you've seen in Google Docs or Google Slides as well, you can have many collaborators. Similarly, with version control systems as well, you can have many collaborators for that particular code. And the advantage of version control system is that it tracks and it saves every single change that's made by all the contributors. So if there are 5 contributors working on, let's say, a particular code, then version control systems allow you to check the progress of all the 5 members, check and see what kind of changes have all the 5 members made. So this prevents concurrent work from conflicting. Okay, so now for you to actually prevent this work from conflicting, now let's say you have one particular code file, let's say a Python file, and you've uploaded it to a version control system. Now, let's say 5 of you are working on that one particular file. 5 of you are making changes to the exact same file. So definitely, maybe 2 of you are even making change to the same sentence. So there will be some conflict, right? There will be some place where the work will not get saved because too many people are working at it at the same thing at once. So how do version control systems take care of that? Well, here it uses something known as a branch. So let me just show you what this branch is real quick. So this is something known as a branch. So let's assume that this is where you are working. In the version control system, you are in the main branch. So we'll speak more about these branches, master branch and all that in the forthcoming slides. I just want to let you know about this since it's a very common and a basic terminology when it comes to version control system. So it's important that all of you know what this means before we proceed ahead. So let's say you are working on this particular branch. That is, you're working on the main branch. You're making changes to that same file only, but on this branch. Now your friend also wants to make changes to the same file. Like we mentioned, if you're making changes to the same file at the same time, there might be some conflict. So what that person does is they create a branch. Now branch is that they take the same file, they copy it onto their system. They basically develop and test it on their own. They make all the changes they want. So you're making all your changes in this branch. They're making all their changes in this branch. And finally, you combine it to form a different version. That is version 2. So this is known as creating a branch. So if you see here, a branch. So like I'll just explain what's a repository and a branch before we proceed ahead, because these are very like basic and important terminology when it comes to all of version control systems, not just Git or GitHub. Any version control system, you'll always hear the words repository and branch. So before we proceed ahead, a repository is a place that basically contains all of your project files. So we kept saying that, version control systems help you control the versions of your software code or projects. So your project will have multiple files, multiple code files. It could be code files, it could be text files, any files. So all those files have to be stored at one particular place. Now that is known as a repository. And a branch, like we just mentioned, is a part of that repository that diverges from the main working project. So if multiple people are working on the same code file, multiple people are working on the same text file, then they can create different branches, work on it separately, and then merge it all to make a final version. Any doubts here? Like this is a pretty important terminology. Any doubts so far? Anyone has anything they want to ask? All right, moving on. So yeah, now what is version control? So now we learned a little bit about a repository and a branch. So let's move ahead. Version control system, like I mentioned, helps you track and save every single change that's made by the contributors. And it prevents, by creating branches, it prevents work from conflicting. And another major advantage of version control system is that if you perhaps lose one particular version, that is okay, because you can just simply revert to a previous version and restore those changes and work ahead from there. Suppose you have 10 versions and due to some fault of yours, you lost version 10. That is okay, because you always have version 9. Of course, version 9 does not have all the changes that version 10 has, but you just have to make those few changes rather than starting the entire project from scratch. That would be even more tiresome, right? So these are the advantages of version control system. They track and manage changes to a project. They track the progress of all the contributors to that project, and they allow you to recover the files if you lose it. So there are two different and two main types of version control system, that is central and distributed. Now what happens in central? In central, as you can see in this picture, you have just one server. Now this one server will have all the different versions of your project. So it will store, like, let's say version 1, version 2, version 3. Now definitely there are multiple people working on this project, let's say. So those people will simply have a copy of the code that they are working on. They'll not have any other copy. They will just have a copy of that particular code or that particular file that they're working on. So all the versions are stored in this one central database, and each person has a file that they're working on. So now they can understand the number of collaborators through this. They can communicate with the collaborators also easily. So that's about central. Now that we have a central version control system, why do you think we needed a distributed version control system? Anyone can let me know? We already have central, right? So we have central where all the versions of that particular code is stored in one particular place, and any other person who's collaborating on that particular project can basically copy those files onto their system, just those particular files, and work on it and send it back to the server, which will have, again, holding a history of your different versions of that particular project. So we have this. It sounds pretty neat. Then why did we need a distributed one? Why did we need a distributed version control system? Again, you can feel free to unmute or put it in the chat. It's completely fine if your answers are wrong. All if you're still learning. So it's totally fine. Don't hesitate. Just type out whatever you think. Why do you possibly think that there was a need for a distributed version control system?
All the team members can access the code.
Sorry?
In distributed. All the team members can access the code in distributed system.
Perfect. Exactly. That is a wonderful answer, Lakshman, and that is exactly what I was expecting as well. So in distributed, what happens is that yes, you have a server computer that manages all the versions of that particular project, but you also have at the local systems of the particular contributors for this project, they also have all the versions. Here, you only have the particular file that you copied or that you want to work on. But over here, you have the entire version that's there in the server. So in this case, if the server crashes, then there's nothing you can do. You cannot recover any of these versions. It's all completely lost. But over here, if the server crashes, you still have one of the contributors that still has all the version histories of that particular project. So using these local systems, you can still recover your project. So that's why we needed distributed. Central is also useful, but distributed gives you better safety and security and recovery in terms of loss of data. So I hope you understood that. So now we have different examples of version control systems. The most popular one and the one that we'll be focusing on this session is Git. So Git is an open source and it's a distributed version control system. We also have something known as Mercurial, which is again open source and distributed. And we have Helix code, which is open source, but it's centralized. So all of these have differences. Although this is open source, both of these are like open source and distributed. They still have some differences when it comes to, let's say, commands or their interface and things like that. So Git is the most popularly used version control system, and that's what we'll be focusing on for the rest of the session. All right, over to Sunil, who will be speaking about why Git.
Yes, thank you, Sneha. So now we just learned what version control systems are. All of you were introduced to the concept of it, and we looked at some examples and we looked at some basic terms, which will be useful going for this slide and the rest of the session as well. So Sneha just mentioned that Git is one of the most popular and widely used version control systems. Why is that? Why choose Git over, let's say, Mercurian or Helix? Let's look at the reasons. So Git has many features that make it as popular as it is today, and some of them are performance. Git is very performant. It performs reliably and strongly compared to other VCSs on all OSs, including Linux and Windows and Mac as well. And new changes can be easily saved on the actual server where all the code lies, and branches like Sneha just introduced to us can be easily compared. So branches, they'll have separate codes, right? Your friend would have done something and you would have made some other change. So you can look at them easily and see what differences there are and see whether they can be combined together to form the final file of code. Another thing, this I guess would be the biggest attraction point in terms of performance, whether you have a small project, let's just say something for your courses, or whether you have a big project, a whole, let's say a whole library you're working on, or even an OS, an operating system, Git can handle it all the same. If it's a large project or a small project, Git is very scalable in terms of your project size. It's very flexible in that sense, and it can handle any size of project, no matter how big or small it is, efficiently and in the same way. Next, Git is very, very secure. It was designed with the security of code in mind to protect the integrity of the user's code and their work. And everything that you input into Git, such as the commits or the commits in the sense the saves you make, whatever code you save, and the file content, whatever code content you have, whatever repositories you are filled with, the differences between one branch and other branch, the version history, everything, all of it is encrypted with an algorithm SHA-1, which is a really strong algorithm. And as such, because of this, you have access to complete code history at any point of time, and each version is securely encrypted. Another one is branch workflow. Now, branch, this is part of the reason why we talked about branch earlier on. So compared to other VCSs, Git has very powerful branching capabilities. Like I mentioned before, branches can be easily compared and merged. And another one is for every single code you change, even if you change one letter or one line, you can make each branch. There's no limit for the number of branches you can make. With one repo, you can make unlimited number of branches, delete them, merge them, do whatever you want as and when required, as you see fit. And the main or the master branch, which is where this is something we'll touch upon later, but it's basically the main branch or the final branch, you can say. I'm sure when all of you work on your essays or any code that you have to submit for assignment or project, you would have made many versions and there'll be one final version you submit. Similarly, for every Git repository, there's one main branch that only has the top tier code. We call it production quality code in the sense that if needed, this can be presented to someone off the bat, and this is what they'll see. Maybe one example I can give you is if you look at any website, right? They'll always have certain content there, and that is the content that the public interacts with, and this is what they want to show the public. So if they want to, let's say I make a website and I want to introduce some change to it, obviously I wouldn't do it on the code which has the actual running the public version, because if I try to make a change and the change doesn't work, that means it will affect the actual public version as well. So I'll make a branch, another branch, and this main branch which contains the running code will be safe. So once I work out all the updates, my version or feature I want to add is fixed, then I can push it or merge it with the main code. And in that sense, the main or the master branch will always have the best version of the code. Next slide. And two other big reasons why people accept Git as a standard for version control system is the distributed development. So like Sneha mentioned, there are two types of VCS, centralized and distributed. And distributed clearly has an advantage over centralized because of its principles. So let's say you're working with a team again, every developer on the team can make their own local repo. And even that local repo itself will have, repo stands for repository, by the way. And even that local repo itself will have its own commit history or a save history. So whatever changes you make, it will be tracked in your local system as well, and will be saved in the actual server when you save it there through methods we'll see later on. And once you save the actual server code to your own local system, you don't need any network connection. You don't need Wi-Fi to make the saves or save your code or look at previous file versions or look at differences between files, look at the branches there are, so on and so forth. And because of how seamless everything is with Git, it's very easy to grow your team. Members can be easily removed or added. There won't be any disturbance. There won't be any hitch. Everything will be seamless. You won't even notice any difference in the whole workflow. And members can work on their own local versions independent of what anybody else is doing or what any change that has come along in another branch. And lastly, the community. Git has a very strong community. It's very popular and it's accepted as a standard, like a gold standard for VCS by majority of developers in the community. And as such, it has a huge amount of support for any issues you'd like to solve or help you need to fix something. And you can even seek outside help through various online forums dedicated just to Git. Yeah, excellent. Now that we talked about Git, let's talk about GitHub. There's a slight confusion always when it comes to Git and GitHub. So hopefully this slide and what I tell you after will clear it up. While Git is the software, it's the system, and it's a whole concept on its own. GitHub is how you can interact with it. It's a web-based interface for using Git. So there is a way you can use Git on its own, but GitHub provides a platform to make everything much easier. It offers the same principles that Git is built upon. So in that sense, it offers distributed version control and managing your source code. It makes it very easy for open source contribution. Open source, if you're unfamiliar with the term, is basically contributing to, if you look at the different types of operating systems there's Windows and Linux. So Linux is what's known as open source, meaning the code that they use to build the Linux operating system is available online, and anybody can download it, change it, and suggest the changes they made in the code to the people who are maintaining the code. So if the people like what you did, they'll add it to the actual operating system as an update or whatever. That's what open source is. A code for something, for some project, is available to everyone to change and can be accepted and included in further versions of the project. So very famous Python libraries like Pandas and NumPy, they're all open source, and those source codes are available on GitHub as repositories, and you can make change to them. So this is what's known as open source contribution, and this is what there's many events to help you with this as well. So GitHub makes it very easy to find what repos you can contribute to and perform the contribution as well. Next, it provides something known as Markdown to help write formatted documents. So anytime you make a change, you might have heard of the importance of comments. Teachers might have told you comments are very important to make it code understandable and things like that. So when in GitHub or in Git, whenever you make a change or something, it's best practice to document the change by describing the change or by describing what was there before, or even describing your whole project on the front page of your repo, which we'll all look at, all of which we'll look at soon. So to make it neater, to make it a bit more understandable, GitHub provides something known as Markdown, which you can think of as a language. And we look at this again, but it offers a wide variety of formatting like bold, italics, underlining, making lists, making tables, including links and other things. So you can write very neat and readable documentation of whatever changes you made. It also doubles as a repository to safely store and showcase your code to the public. So if you worked on any team project, you might have done something like the following. You have one initial code file, let's say a Python file, then you make a change and your teammate wants to make a change too. So they make a change on their own copy of the file, and you both send the copies over email, and you look at the changes, then you incorporate the changes into one final file, and one of you has the actual copy. That might have been a hassle because every time you change even a small thing, you want to keep track, so you keep sending emails back and forth. So because of the way GitHub works, all that is done away, and it removes all the hassle of that. Also, you might be having that fear that when you work so hard on a certain project, you'll have the fear that what would happen if my laptop got hit with the virus or it suddenly stopped working. You won't have any backup for it. So you can even use GitHub to safely store your code. So in case anything, you have a problem with your laptop, or even you want to switch to a new laptop, you can, instead of copying the project files from one laptop to another, you can push them all to GitHub and then bring them back to the other laptop. And lastly, this is probably the biggest or the most important point to engineers or people who are looking to for a career or any admission afterwards. Anything project you work on, any project you work on that you feel you're very proud of, or you feel shows your capability or knowledge in a language, you can upload to GitHub. And when you're making a resume, you can link the GitHub account and recruiters will look at the GitHub account, and once they see the projects you worked on, they will get an understanding of how knowledgeable you are, and they'll get a feel of what you are capable of as a programmer, and it could increase your chances of admission or selection. And just like Git, it has a huge community and people are readily available to resolve issues and ask for help. Let's say you've started using Pandas, the Python library used for manipulating data, and you find some issue. You're trying to use it with another library, but there's some version compatibility, and there's a bug that you just can't get rid of. You can hop onto the GitHub repository for Pandas, go to the comments, go to the forum. There's a way of doing this, and say that this is the issue I've been experiencing, how do I resolve this? And you'll get instant replies from community members who've either faced the same thing and they want to draw attention to your comment by likes, and it'll attract the people who actually maintain the repo to come help, or people who already faced the issue and resolved it, they'll help you as well. So this is all about GitHub. Just to reiterate, GitHub is the way you can use Git. You can interact with Git. It's a website, and it's a web-based interface, and Git is the actual software that GitHub is built upon. Yeah. Next.
Any of you have any questions so far? Any questions at all? Like anything you want us to repeat? You can either unmute and ask us, or you can ask it in the chat. Anything you want us to repeat. And anyone wants Sunil to again explain what the difference between Git and GitHub is. That is a pretty important concept. If anyone wants us to explain it again, please raise your hand, use the raise hand reaction. We wouldn't mind explaining it as many times as you'd like. So don't hesitate. Or if you've understood it, oh yeah, okay, there's someone who wants you to explain it again.
Yeah, there's. So you want me to explain the difference between Git and GitHub or anything else I've talked about? Could you clarify? Maybe in the chat.
Git and GitHub.
Right, yeah. So do you understand what Git is, whatever Sneha explained? Okay, yes, I'll explain what a local repository is also. So, okay, it seems you've understood what Git is. So Git is a version control system. It's a software. It helps you do whatever Sneha explained. Now, GitHub is a web-based interface. It's like a website. Maybe Sneha, you could quickly show them just once so they understand just show the website once. We wanted to come back to this later, but to clarify, we'll show you now itself.
Exactly. So this is what GitHub looks like.
This is what GitHub is. We'll be coming back to this and explaining everything you see on the screen later on. But GitHub is a web-based interface. It's a website that is built upon Git. So whatever Git offers, you can access. You can utilize the principles of Git, such as a version control system, branches, repositories through GitHub. It facilitates the principles of Git. Is that better? Do you understand it now?
Yes.
Okay, cool. And on to the next question. Harshita asked, can you explain what is a local repository again? Yes. So as Sneha explained, whatever version control systems, basically they have, if you look at distributed version, could you go back to the slide again, the distributed and control central. Yeah, so as you can see here, if you look at central version control system, there's a whole server that holds the actual code in the database, right? Whatever, let's say you're working on a simple Python file, Python program. So first version, it will be stored on a database. Then the second version again in database. So that is the central one. Distributed one, you can think of it as everyone. Let's say you, me, and Sneha are in a team, right? So each one of us can have our own mini database in our own laptop. So we can work on our own changes there. And then again, through GitHub, this is where GitHub comes in. It's like you can, whatever, let's say you make a change in your own local laptop, the one you're on attending this meeting on right now. You'll have, as you can see on the picture, everyone has the same version database. So whatever updates we made to a file so far, all of us will have the same copy of that mini database. And let's say you make a change in one file, then you add version 4 to your own version of the mini database. So we should also be updated, right? That we should know that, oh, Hashita made the change, so we should also get the version 4. So that we'll get through GitHub is the medium, you can say. Let's say all of us are working on a 3D model, right? And there's one box, there's a big box. So you take the 3D model, you add some changes to it, you put it in the box, then I can come and look in the box again and see that you've made some changes. And I can take the model, do whatever I want, put it back in the box. Then you can come and check that, okay, you know that I've made a difference. Similarly, you can take a copy of the version database from GitHub onto your own local laptop, do whatever changes you want, make another version of the code or the project you're working on, then put it back into GitHub for the rest of your team to see and understand that you've made a change, and that is the updated one that they have to work with. Is that better?
Yes. Thank you.
Yeah, no problem. Any other doubts? Feel free to ask. Even if you want me to repeat something or any of us to repeat anything we've said so far, don't hesitate.
Samson has also wonderfully explained it in the chat.
Yes.
You can all read through that as well.
Yes, exactly. That is a wonderful analogy. Please read that.
So if any of you have any doubts, again, don't hesitate in asking, because this is an important concept, and it's better that all of you understand it clearly. So all doubts are welcome. All right. Okay, so then I proceed ahead for now. We'll move on to basic GitHub terminology. But before that, can anyone here tell me what a branch is? Like we discussed what branches are before. Anything that you understood of what a branch is, you can feel free to unmute, or you can type it out in the chat as well. What do you think a branch is, or what's your understanding of a branch? Anyone? Again, we've spoken about branches briefly so far. Whatever you understood, you can just let us know. And even if it's wrong, that's completely fine. We'll correct you wherever. Anyone? Or is there someone who didn't understand branches? All right, I will just explain it again. Okay. Neil mentioned what a repository is. So repository, again, like he mentioned, is basically the place where all the files of your project are contained. So this is the main database for all your project files, and any changes you make, all the version histories also will be available here only. So what this repository helps is that it allows you to manage the work and the flow of the project. That's what a repository helps you with. Now for a branch, let's say you're working on a particular project, and there are, like, let's say 2 or 3 of you working on that same project. Now there is this one file in that project that all 3 of you are simultaneously working on. Now if all 3 of you are simultaneously working on it at the same time, there might be some conflict, because you might make one change, another person might make another change, another person might make another change. It becomes a whole mess. Rather than that, it's better to create your own branch. So branch means, let's assume that so if you look at this icon, let's assume that this is the main working repository line. So this is where the major changes of the project are happening. Now you want to make a change with code A. Your friend also wants to make a change with code A. So what you and your friend do, you create branches. You take this code, this entire code, copy it onto your local system, fix it there, and then merge it back here. As in, this is the main working area, if I may say so. So you and your friend, you create a branch. Like, branch is literally like the branches of a tree. There is the main branch, and there are, other branches where there's leaves and others. So think of it that way. The main branch is where you're working on the major changes to the project, and these side branches are, perhaps some fixes, some features, and other things that you're adding to this main working line. And then you're doing it separately so that there is no conflict. There is no conflict. There is no mess. It's all clear. It's all organized. You all can make your different changes and then merge it back with this and merge it back with the actual working code. Did you understand that? Any other doubts so far? Okay, so I'm just looking at this now. A separate, Harsh has mentioned that branch is a separate address for anything you commit. And Srinidhi has mentioned an instruction. Srinidhi, could you elaborate on what you meant by an instruction? It's completely fine if it's wrong, no problem. It's a very interesting answer. That's why I just want to understand what exactly you meant. You could put it in the chat as well. All right, we'll move on for now. I will come back to whatever Srinidhi has to explain. Okay, so we'll move ahead. Now, let me show you how a repository looks like on GitHub. So when you open Git, the first thing you do with GitHub is create an account. Now you can just create an account using your email ID. It can again, it can either be your Amrita email ID or your actual Gmail. That depends upon your own personal use and personal choice. So when you first open GitHub, once you've made an account, you'll get something like this. Now all of this will be empty. So it's best practice for you to always fill in these fields. So these will generally be empty fields, you can write in whatever you want. So it's always better for you to give an introduction about yourself, given some topics that you're interested in, what you're learning, and what you'd like to collaborate on. So when someone else, it could be either a friend or a recruiter, looks at your profile, okay, they know what you're interested in, what you're working on. And if their interests match, then you guys can collaborate and work on a project together. So that always makes it better. So it is best practice to just have a small introduction about yourself on your personal README. All right. So now let's look at a repository. So we've been speaking on and on and on about repositories. What does a repository look like? So this is what a repository looks like. This is a repository. This is what it looks like. So you can see here, like I mentioned, a repository contains all the different files that you require for your project. So for this particular project, I required some code files and some text files. So all of that is present here. And now every repository has something known as README. What is this README? README is basically a text file, if you can say that way. It comes automatically with every repository. And this allows you to describe all about your project. So you can describe about your project. You can describe what are contained in each of these directories in your project. So there are multiple directories, as you can see. So in your README, the best practice is always to first write what is the project about. If the project uses more than one technology, so for me, I've only used Java. But if the project, suppose the project uses Java, Python, and maybe C++, or any other language and technologies, it's always best practice to mention or write down all those as bullet points. Then you can say how to use, as in if a third person or a third party is coming to your public repository to view it, then there would be so many files, so many folders, they would not know how to navigate through all of this. So it is again best practice to always write how to use this particular repository, how to navigate, which file to use first, which code to download, which code to use. So it's always best practice to write this. And directory contents, like I mentioned, it could either be a recruiter or your friend is coming to see what work you've done on GitHub, what kind of projects do you deal with. So when they come, and if there's no README, there's nothing written in the README, they come to just see this code and text files. Actually, even if there was no README and you guys itself came to see this code and text files, wouldn't you be confused? Wouldn't you think, okay, what is contained in this code? What does this project do? There's just some random code, random text files. I don't understand. So for everyone, a recruiter, your friend, anyone else who's coming to this public repository, for them to understand the workings, it's always good to give a description and also a brief on how to use it or what is the output. So this is a relatively small project. That's why there's only so much in the README. If it's a larger project, you can have like different directory contents. You can have screenshots of outputs and things like that. So this is how a repository looks like. This is all about README. Now we also discussed something called branch. So if you have to create a branch, it's right here. So you can see, as Sunil mentioned, main or master branch is the main branch where, if
Sneha, 1 second.
Yeah.
Srinidhi replied back. She put something in the chat.
Yeah, I'll just.
So if you want to hear.
Yeah, cause a computer to begin executing a different instruction sequence and thus deviate from its default behavior. That is perfect, Srinidhi, amazing. Yeah, that is what I mentioned as well. And I guess through this, I can see that you've understood it well as well. Good job. Anything else anyone wants to ask me right now? Or is it okay for me to proceed ahead? Okay. All right, so as I was mentioning, this is all about a repository and the main component of a repository, which is the README. Now we've been speaking about branches. So as you can see here, this is a main branch. Currently what this entire repository is what's present in the main branch. So the main branch is the final branch, or the branch that can be presented, or it can be deployed, it can be executed and things like that. Now for this project, since I was the only collaborator, there was no one else to create different branches, but you can always type in, let's say you want to create another second or something like that. You can always create this branch. When you type it in here, you can always create this branch and start working on some other code on this branch. So that is all about a repository and a branch. Now let's talk about issue. So this is a new GitHub terminology. Issue. What are these issues? So issues are basically tasks or improvements or any type of questions that are related to the repository. Now suppose you as a GitHub user, you're going through multiple repositories. Let's say you're going through either your friend's repository or some organization's repository, some community's repository, and you look at it and you suppose you're going through a code file and you see, oh, there's a bug in this code. This code is not running. There's a bug and you want to fix it. So as Sunil mentioned, there's something called open source contribution, as in you are contributing to these public repositories. So let's say, again, you go to a public repository, you find that there's some sort of bug in this code and you know how to fix it and you want to fix it. So what you do in that repository is you raise something called an issue. So this issue would mean that you're explaining that, okay, hey, this particular Python code has a small bug and it should be fixed in this manner. And you will probably ask them. So every repository has a maintainer, as in the person who controls or runs that repository, the main person who heads that repository. So you're basically asking the maintainer and letting the maintainer know that, hey, your repository has some errors and I would like to work on fixing them. So that is what an issue is. Now, if suppose, so this could be one use of an issue. Another use is, suppose that you all of you will work on like projects in college, some project, many other things like that. So what you can do is you can use GitHub for that. So maybe you have uploaded up like half of your project. Now there are 3 of you and you still have another half of the project left. So what can you do? You can divide tasks. Now instead of typing out these tasks in a Word doc or an Excel, you can just create issues for different tasks. So you will know that these issues are open. Suppose let's say someone has to finish a Python file, another person has to finish typing out the report, and another person has to finish making the slides. So then there are 3 different tasks. So then you can create 3 different issues for these 3 different tasks, so that people will know that, oh, okay, so I am assigned to complete this particular PPT. I am assigned to complete this particular code. So that way you can easily track the progress of your repository and the progress of your project as well. So I will show you how an issue looks like. Let me actually take you to a public repository. Okay, so this is a Women Who Code. Women Who Code is an organization, and this is the repository of that particular organization. Now, this is the issues tab, if you can see here. So issues are present here, and there are people who have opened issues. So I have opened an issue over here, where basically I've stated that, there is this one particular code that I would like to contribute to this repository. So this is one particular code I'd like to contribute to this repository. That's the issue or the task that I want the maintainers of this repository to assign to me. So I have been assigned this particular task and I can continue working on this task and making a meaningful contribution to this repository. So that is all about issue. Now, now that issue has been assigned to you, that means that you have divided the tasks as 3 different tasks, or like what I did right now. I went to a public repository of a different organization and said, hey, I want to add this particular feature to your repository. Can you please assign this to me? So now you've created an issue. The next step is to work on that issue. So if like me, if you've gone to a public repository and you wanted to work on a feature, the next step for you is to actually work on that feature and give it back to that repository. Or if you're working on a group project and you've divided the task, the next step is for the team members to work on the tasks and again push it save it back in this repository. So for that, first what you need to do is a pull request and merge. So maybe you are actually, before that, if you're working on a public repository, that is, if you're working on a repository like this, like let's say a particular public repository of an organization, like I mentioned, GitHub allows you to have versions of that particular repository on your local system. So for you to work on this, you will not directly be working on this organization's code. You will need to create a copy of this entire code for yourself. So that is known as forking. So this is a simple way. All you have to do is when you look at, so this is again, like I mentioned, this is the repository of women who code. So now I basically want to contribute to this repository. So the first thing I will do is fork it. Again, I will not be doing this now since I have a forked copy already. So when you click on this fork, what will happen is it will take a few minutes and then it will just automatically create a copy of this entire repository onto your account. Let me show you what it looks like. So I have already forked this repository onto my local system. And this is what it will look like. So it will say Sneha and the Python because it's my local copy of this repository. So I have everything that's there in this. This is the original repository. So it's forked from this particular organization's repository and I have this personal copy on my personal account. So now I can continue working on this. So that is about fork. And now if you have to, like I said, so you've taken an issue. Now you've forked that repository onto your personal. So it's a copy of a user or an organization repository that lies in your personal account. Now what you have to do is you start working on the changes. So I had to work on a particular issue. I had to add some features. So on your local system, you start working on those changes. And what you do is a pull request. You give a pull request, as in once you're done with these changes, you make a pull request. So what's a pull request? This allows the contributor of a repository to inform the maintainer of that repository that they have completed a feature or completed that issue. The issue or the task that was assigned to them, they have completed it. That's what a pull request is. So again, let me go back here to show you what a pull request looks like. So if you remember, I had created the scanny edge detection issue. Now, this is what a pull request looks like. So this is what a pull request looks like. So I have basically I have completed whatever work I had on that particular issue and I have pushed it, like as in made a pull request to this repository to let the maintainer of this repository know that, hey, I created so-and-so issue and now I have fixed so-and-so issue. So can you please check it and let me know? So what will happen is the maintainer of this repository will review whatever you've done. And if they feel that you've done a good job and they feel that, oh, okay, whatever you've worked on is amazing and we can use this, then they will merge the changes. So once the feature gets approved, you can merge the changes to the main repository. So it looks something like this. So my feature got approved. I worked on this particular feature and it got approved. So now these changes have been merged to the main repository. As in, if you go back here, basically the code that I had worked on is already present in this repository now. So if I go here, I worked on Canny Edge. So that Canny Edge is already present here. So the maintainer of this particular repository approved my changes and merged it to their main branch. So that's what pull request and merge means. Now what does commit mean? Commit basically means saving the changes that you've made. Saving the changes you've made to a file or a set of files. That is commit. So these are the basic GitHub terminologies. Right now we'll be moving on to creating, I'll be showing you how to create your own repository and I'll show you a little bit more about GitHub and how to actually navigate around it. But before we proceed, does anyone have any questions so far? So we spoke at any of the topics that we discussed about Git, GitHub, these basic terminologies, anything. Any questions at all? You can either ask it in the chat or you can feel free to unmute and ask. Or any part that you want us to repeat again, we'd be really happy to do so. Anything at all. All right, I'm assuming all of you understood. If there's anything, you can feel free to either put a message in the chat box or you can feel free to interrupt us as well. Okay, now once you've created a GitHub account, the next thing to do is to upload your projects there, right? So for that, you need a repository. So I'll be showing you how to create your repository. If you already have a GitHub account, you can follow along. Okay, so Lakshman asks, commit means saving changes to our local repository or the main server. Okay, so it means both actually. So if you have taken a copy of that particular, let's say, repository onto your local system and you've committed, that means that you've committed to your particular local repository. Understood? See, once you've committed to, so you've made a change, you've committed it to your local repository. Only after you create a pull request will it be approved by the maintainer of the main repository. Does that make sense to you, Lakshman?
Yeah,
I'll be
okay.
showing you how to commit. Sorry?
Yeah, understood.
Understood. Okay, fine. All right, so now I'll be showing you how to make a new repository. And if you've already made a GitHub account, you can feel free to follow along. So what you need to do, so first you have overview here, go to repositories, click on new. Now let's give this repository name, let's call it Git, which is the name of this event. And it's always best practice to give a description. So when someone else is coming and looking at your repository, they'll know what it's all about. So let's say, now you can either make this repository a public one, so anyone on the internet can look at it, or you can make it private. And whatever you've done, if you made it public or private, once you've saved this repository, you can always change it. So you can change a public repository to a private and a private to a public as well. And now we need to add a README. README is important, like I explained. README is what will help you understand everything about that particular project. So you need to add a README. You need to make it public or private based on your interest, and you will call it something, and it's best practice to give a description. So this is all you need to do, and just click on create repository. So this is it. So this, you have now created your very own repository, and this repository has nothing but a README file. But yes, this is a repository, as you can see. And now this is a README file. Now let's start off by making some changes to this README file. So maybe, okay, so before I continue, if you remember from what Sunil spoke, he said something about markdown. So this is what a markdown is. A markdown allows you to create lists, to bold words, to italicize words in a README. So suppose I want to create a list and say, this is ACM, maybe create another list, say ACM-W. This is how you create lists. So this is what it will look like. ACM, ACM-W. This is how you create list. Now let's say I want to make some text in bold. So this is how a bold text would appear. Now let's say I want to make some text in italics. This is how italics would appear. And let's say maybe I want to add some link. So then what I would do is I would add the name of link here. And then let's say I'm just adding this only again. That's a link. So this will come here like that. And you can always click on it. Okay, this will leave this site for now, but you can always click on it and go back to this repository, or you can add whatever link you would like. So this is a simple markdown. I think there will be a link in the chat which has the different kinds of markdown that you can use to make your README look more attractive and make sure that you've emphasized on the right things, and just make it look neat in general. So this is all about Markdown. Now you can always commit changes. So this is what Lakshman, this is what I was talking about. So you can commit changes. Now before you commit a change, you can either have a message. So the pre-given message is update readme.md. You can change it to whatever you want. Maybe understand. Understand readme. And you can have an other optional extended description if you want. Again, like I've been saying so far, it's always best practice that whenever you're making some changes to the repository, to always create a new branch and do it. But in the interest of time, we'll just make all the changes directly to the main branch. So now you can commit these changes. Commit, which means saving in this particular new repository that you have created. So you can see now that the list you created, the bold, italics, and the link as well is already present here. All right, now let's go back to the repository. So we have a README. Now what if I want to add more files to this? So let's say I want to add a file from my local desktop. So what I do is I click on add file. I click on upload files. So I want to upload a file from my given desktop. So I can drag files here or choose them. So I will choose them. And let's say I'm choosing something here. So now I have uploaded a new file called to some problem and Java. So again, so now that you have made a change, the next step is for you to save those changes, which is commit those changes. So you can say added Java file as your message. So these commit messages are very important for you to understand the different changes that you've made. So now once you've created or once you've uploaded this particular file, again, we'll be committing to the main branch only for this session. So you can always click on commit changes. And there you have it. So you have the README with the different changes. And then you have this particular Java file that you created and the Java file that has been uploaded to this particular repository. Okay, so far we learned a lot about GitHub. We learned the terminologies. We learned how to create a new repository. We learned what a README is. We learned how to use Markdown to change the different links or italicize or bold or basically change the layout of a README using Markdown. And we also understood how to use this GitHub interface to add the files you want to this repository. So far, does anyone have any questions? Any questions or anything you want us to repeat again? All right. Okay. So then over to Sunil, who will be explaining all about Git. I think Sunil will be sharing his screen now.
Yeah, just give me a second.
In the meanwhile, any questions or do you want us to repeat anything? Have you understood how to
take any questions first, then I'll share my screen.
Yeah. If you have not understood how to create a new repository or want us to show that to you again, or like basically whatever hands-on I just did, if you did not understand that, please raise your hand. Or you have any doubt, please raise your hand. Any doubt, anything you want us to explain, even from the previous topics like Git versus GitHub, version control, anything at all, or any other particular doubts you have from what we just did. All right, I think you're fine to proceed for now. Any other doubts, you can continue to ask us in the chat, or you can feel free to interrupt us and ask us as well.
Yeah, good. So I'll share my screen. Is it visible?
Yeah, it's visible.
Yeah, cool. So before we go into the next topic, again, just to reiterate, you can think of it as a whole picture of the workflow of Git or any project you start. So you have the actual branch, you can think of version 1, and as Neha showed, when you can create a branch and it exits on its own separate code base, you can think of like its own separate database. Then whatever you want to develop and test, you do it here. Then finally you merge it in, then you push it out in the world as any product or whatever. So that's all about the overall picture for GitHub and GitHub for any project you do. Now let's look at some commands. You might be wondering what are these commands and what is left to show you when Sneha has already shown you the hands-on for creating or uploading files and creating a repository through the website. Well, there's actually another way to do it. I'm sure many of you are familiar with the command line interface that comes with Windows. So if you go into your Windows system and type CMD and search it up, you'll get the command Windows prompt. Similarly, Git has its own command and interface called Git Bash, which helps you work with your local repository and save your changes in the actual project on GitHub. So we'll look at that now, a quick demo to show you the two ways you can deal with the project. So before that, let's quickly look at the basic commands you'll be needing to start out. So first you have git clone. Basically, this is how we've been talking about local repositories, right? So this is how you get the actual code that's already existing to your local repository so you can work with them. Then git branch is basically listing all the branches in a repo, and it'll even show you which branch you're currently in. And git checkout. So like I mentioned, it is best practice to never work on the main branch, especially in a team, because that main branch contains the final version of all the changes and all the features. So if you want to work on something, it's best to create a new branch and work in that branch. And by default, when you clone something to your local repo, you'll always be stuck in main. So always remember to check out or switch to another branch using this command and work there. Then git add. Okay, this is something new that we've never mentioned up till now in this session. So again, please listen carefully, and if you have any doubts, please feel free to stop and ask, or even after I'm done. So I'll start off with an example to make things easier. Whenever you return mail to someone, if you stop halfway or something happens to your laptop, or your laptop shuts off, or you have to go do something and you accidentally close the mail you were writing, Gmail doesn't immediately delete the mail. It doesn't put it in trash and permanently delete it. It creates something, it creates a draft of the mail. So wherever you left off, that whatever you've done till then, it'll be still saved. And if you want, you can come back to it, add something else, then finally send it to whoever you want to send it to. Similarly, git add is, let's say you've downloaded or brought in or cloned the project you've been working on in the repo to your local system. Then you've made some changes, and now it's time to push those changes back into the actual server on GitHub. So first you have to let Git know that, okay, this is the actual thing that's been there. These are the changes I've added. So please note that these are the changes I've added to let Git know that you perform the command git add. So what this does is it adds these changes, tracks these changes by adding them to staging area. Now staging area is very similar to the concept of draft emails that Gmail keeps track of. Whenever you write a mail, it goes into draft. So similarly, if you've added 2 lines and you write git add and you leave it there and don't do anything else, then you can add more changes, then git add again. So it will add on to whatever changes you already said previously, and you can keep adding until you're satisfied that, okay, these are all the changes I want to make, and now it's time to finally push. So git add does that. Whatever changes you continuously make to your code, at once it will accumulate until the time you write this command or execute the command. So once you do that, it will be added to the staging area or draft area until you perform any further action. So the further action, one of the next steps would be to make something known as a commit. Now I've been trying to using this word throughout the session, and now it's time to finally make sense of it. So once you go through this session, you can go back and read the slides and appreciate much better the content we're talking about with respect to this extra knowledge you have. So commit is basically, you can think of it to use a save changes. This is like a checkpoint, like how Google with all the services provides like docs and slides and sheets has the version controls as checkpoints you can go back in. Think of it like a game. Anytime you do something significant in a game, the saving icon appears and you can restart from the save point if you mess up in the future, if you die in the game, or if you did something you don't like, you pause the game, hit restart, and asks you, do you want to start from your last checkpoint? And you say yes. Similarly, Git commit creates that checkpoint for you. So going forward, if you mess up anything, you can revert back to this. Similar, the same way you can do it in a game, or the same way you can do it in the Google Docs, Sheets, or Slides. And even in Windows, you can look at previous file versions. So you can restore them if you messed up the version you're working on. This is all stuff you've seen before. Maybe you haven't explicitly been put through, been showed that concept in this way, but you've all familiar to this concept. That's what commit is. Finally, you've added whatever changes you want to add. You've created a checkpoint in the whole process. You've created that version, so that version gets added as a history now. Now you need to tell your team that, hey, look at these changes. Now you need to make the changes available to your team. That's what git push does. The moment you do git push, it will push those changes onto the actual server, the main one on GitHub, and anyone can see that, oh, you've made this change here, this person's made this change. Now I know that this is the latest one, and if I want to work on the latest one, I can do the next command, which is git pull. So once you've pushed your changes, they need to look at the changes and they need to get those updates. So if they want to get those updates and work on the latest version of the whole code, they can do something known as git pull. Now these are the basic git commands you need to have knowledge of to get started with. I think there'll be a couple of links in the chat containing a couple of other basic commands. They are not very important they're not something you encounter very frequently, but it's still good to have an idea of them, especially when you're get more into using Git. And if you already used Git for a couple of months, then it's good to have an idea of them so you have a better understanding. Now with this out of the way, we'll have a quick, I guess you could say, final hands-on session. Before we move on to that, do you have any questions? Does anyone have any questions? You can leave them in the chat or unmute and ask. I realize we've taken a bit of extra time. This won't take much time at all, since Sneha's already explained all the basic stuff. We'll get straight to the demo. This is just to show you how to do things from a different perspective. So if anyone has any doubts, you can ask them. Otherwise, we'll get into that. All right, cool. So like I mentioned, Git has its own command line interface, and it's a software you have to install. We won't be showing it in this tutorial, in this session to preserve time, but we will send you a resources list that has instructions on how to install it. So I will unshare and share my screen again, 1 second. Yeah, so once you install Git, anytime you look into any folder on your Windows system, if you right click, you should see these two options here. Git Bash is what we'll be focusing on, and this is the command and interface, and it looks like this. So there are certain steps to follow when you first use it to set up your username and stuff. That will all be clear in the instructions we'll be providing to the resources. So before we do that, we need to have a repo to work with. So I've already made a repo here. So what we're going to do is first get all this, whatever's here right now, all the files here, to our local by using the git clone command. So any repo, you'll have this code button here, and you'll have this link, which is basically you can say the address where the code lives. So you'll be getting it from this address. So now we'll move here, and when I do git clone and paste the link, you can copy the link from there and paste it here. Once I hit enter, it will say cloning it to git set event, which is the name of the repository. You can see here, and I have this folder here that contains whatever files I have here, right? So I've already made a file beforehand just to show you the working of Git. This is just a simple Python program to take two numbers and print the average of them. So let's say you've made this and you want to add it. You want to add it as the to the repository. So you copy it and then you set it here. You paste it here. Now this, I open this command line from here, right, from outside the repository. So if you want to commit or perform any of the other commands we talked about apart from clone, you'll have to go into the repository folder and open git bash again from there. So once you do that, this is a little different. You can see that it has main here, which indicates the branch you have. And if you do git branch, which is the command to list all the branches, you can see only the main branch is there. And you can see it's selected in green to show that I'm in the main branch. Now, like I said, again, it's best practice to switch branches in your team, but since it's only me doing it, it's okay. Next is the git add command. There are two ways to do that. If you've added multiple files, you can do a dot, which will add all the new files in the repo folder, or you can add specifically the file you want to add. So I'll do the specific file way. Once you do that, now you're telling Git that, OK, I made this change, so please keep track of it. And now you can do commit. And it's always best practice to add a message saying that added average file, much like what Sneha did with the some problems she added. So added average Python file. Once you do this, so you can see here that it says whatever changes you've made. So it says one file added, average.py, 8 insertions because there are 8 lines. So this is the checkpoint it's created. Now you can get back to this version of the repo at any point in time. The last thing to do would be to hit git push, which will push the changes to the code, and we'll see it take change in the actual place. So once that's done, you'll see this same command prompt again. And if I go and refresh my page, hello, can you hear me?
Yeah, you're audible.
Yeah, so as you can see, the average.py file is here, and you can even click on it to verify that this is what I've added. And you can even see the commit message here. So that is all about doing things from the command line. And yeah, so that's about it for the session. So if anybody has any doubts, they can ask us, or if you have no doubts, you can leave the session. Thank you so much for attending, and thank you for staying on with us for this long.
We're really sorry we went past the time, and thank you so much for staying on. And if you have any doubts, please ask us. Don't hesitate in asking us any doubts. Again, you can also ask these doubts in the WhatsApp groups that you're a part of at any time you'd like. And if you have any, when you're installing Git on your own, which is very important, you can always ask us if you face any errors and others. And do fill the feedback form so we understand what you liked about the session, what you didn't, and how we can improve in the future as well. You're welcome, Srinidhi. You're welcome, Asmita. If you have no other doubts or queries, you can feel free to leave the session. You can always contact us on WhatsApp for any doubts you have with regards to anything.
Yes, you can contact either through the groups or personal chat. We'll always be happy to answer your doubts, and we'll answer them as soon as we can. When you say how to find someone on GitHub, you can once you have their username. I guess I'll quickly just show you. So here you can see my username is Sunil87. So it'll be under your profile, the second name or the username. So you can search here, and you can say all of GitHub. So if you do that, and if you look at users, you'll see my name here. Similarly, you can search for issues, repositories, or code, anything like that, even topics. So that's how you find someone on GitHub. Is that, did I answer your query? Yeah, no problem.
Anyone has any other doubts that they want to ask us right now? You can feel free to ask us anything, any doubt you have of any sort. If there are none, don't forget to fill the feedback form. And if there are none, you can feel free to leave the session. Thank you so much for attending and for staying with us till the end, even though we overshot the time. Any other doubts, the people who are remaining? Or any concern, any suggestion, anything at all, you can feel free to unmute and let us know, or you can type it out in the chat as well. And if there's nothing, you can feel free to leave the session. We're done for today. We once again apologize for the inconvenience.